Welcome to this edition of Parent Quick Smart's 3rd grade Unit 3. In this unit of study, students will explore and understand the concept of area, determine the area of rectilinear figures, explore and understand the concept of perimeter. Typically, when we learned how to find area, we were told the formula and applied it any time we needed to find area. Area equals length times width, or also known as area equals L times W. We may not have understood why using the formula worked. The 3rd graders are learning area conceptually by learning the meaning of the term area before learning the formula. We'll learn strategies for finding area before learning the formula, and we'll make sense of and learn that you can use multiplication to find area. Here's a possible task your child will be posed to explore what area is. The task is to put the rectangles in order from the one that covers the largest surface to smallest surface. Notice we have not mentioned the word area. By the end of this task, we want the children to understand that area covers a flat space, and we also want them to discuss the strategies they use to order the shapes. Here are possible ways your child may try to determine which rectangle has the greatest surface by spatially lining up the rectangles or even folding to determine the similarities and differences. Children may even possibly cut to determine which shape covers the greatest amount of space. After students have discovered the idea that area is the amount of space that's covered, they can be given square units such as tiles. Based on the standard, they need to understand that the square units are covering the space without gaps or overlaps. One of the standards for 3rd grade include measuring area by counting unit squares. At this point, we would give the students square tile counters and have them cover the surface with the square units without gaps or overlaps, and then count to determine the area. Here are 2 sample problems your child may be asked to solve to find the area by counting the squares. Another standard in 3rd grade relates finding area to multiplication. Once again, we aren't telling them the formula and asking them to apply it to the model. We are having them discover the formula based on the relationship between area and multiplication arrays. Students may even be challenged to find the exact area with square units with a small sample of square tiles so they can see the connection between equal rows and repeated addition or multiplication. So if they find the amount in one row, which would be 5, and then they find the amount of rows, which is 3, they can determine 3 rows of 5 or 3 groups of 5 is 15, and that is related once again to multiplication. So if I just multiply the length and the width, I can determine the area. Here's a sample task where students would have to apply the connection between area multiplication or repeated addition. They would see that A is a more efficient strategy to finding the area of the rectangle rather than counting all of the unit squares. Once students have the understanding that multiplication can be used to find the area of a rectangle by multiplying the length and width, they could find the area of this rectangle by applying that understanding. As a part of the Florida Mathematics Standards, your child will also be expected to determine the perimeter of polygons, find unknown side lengths of polygons to find the total perimeter, and look for patterns among rectangles with the same perimeters and rectangles with the same areas. We want children to understand that perimeter deals with the distance around a polygon. A task your child may be presented with is the problem: Ben's garden has a perimeter of 32 feet. What could Ben's garden look like? And thinking about that same problem, we want to ask questions to get students to think deeper about perimeter and area patterns. Example questions may include, if I have the same perimeter, will I have the same area? Is there more than one rectangle that could have the same area? We will also look for patterns among rectangles that have the same perimeter. We may pose the scenario. Here are 2 examples of Ben's garden. How are they alike? How are they different? We would want the students to see that they are both correct because they have a perimeter of 32 units, but they have different areas. We could even ask which would be the garden with the greatest area in other questions. Based on the standard, students are also determining unknown side lengths to find the perimeter of polygons. When asked to find the perimeter of this rectangle, your child would need to recognize the attributes of rectangles, including parallel sides have the same length, and apply that to determine the perimeter. A common misconception children have is just to add the two numbers present or multiply them. It's important to keep perimeter scenarios in context so this confusion doesn't happen. This problem-solving scenario helps the children put the concept of perimeter back in context. Tony decided to place a fence around his dog Scruffy's rectangular playpen. The playpen has a length of 7 yards and a width of 4 yards. How many yards of fencing does Tony need to purchase? These questions can help to deepen your child's understanding of this unit. How does the concept of multiplication connect to area? What is a real-world scenario where you would need to find the area of a figure? What is a real-world scenario where you would need to find the perimeter of a figure? How are perimeter and area alike? How are area and perimeter different? What is a quicker way to find the area of the rectangle? What is a quicker way to find the perimeter of the rectangle? Here are some examples of area you would want your child to look for. Square tiles on a floor. Measuring to find the area of a carpet or wood floor. Using post-it notes or square units to cover a space and determining how many of those units it took. Area rugs. And square window panes on a window surface. Some examples of perimeter in the real world may include fencing around a pool. You could pose the problem, we need to replace the fence around our pool. How many feet of fencing will we need to surround our pool? And this task, if we walk all the way around Central Park, how many yards did we walk? To continue to work together to support your child in mathematics, please be sure to keep in communication with your child's teacher. You may also utilize the resources available on the thinkcentral.com and be sure to visit the district's math webpage. Thank you. See you next episode.